So far, we have been modeling voters' decisions based on how well their stances on a set of issues match each candidate's stances. But even with all the complications we've thrown in, we have left out one important factor. Voters want their candidates to win. Year after year, it's difficult for even the most stalwartly principled voters to select a candidate based on the issues they care about when their closest matched candidate seems to not have a chance at winning, while a candidate they're very opposite from continues to win handily. It's at this point that a voter might consider voting for a candidate who is less of a match, but who has a better chance of winning to keep their opposed candidate from winning. The net result of this behavior is called the spoiler effect, and in today's video, we're going to see if we can observe the spoiler effect in action in our code. Observing the spoiler effect is going to require some pretty substantial changes to our code, although the underlying mechanism is going to be the same. Up until now, our voters have been pretty stalwart on their principles. They've been randomly distributed on their principles, but when they have those principles, they've been pretty stalwart on them. So what we're going to do in the voter class to be able to observe the spoiler effect is we are setting this win threshold. So this is the minimum match score that a voter is willing to consider a candidate for. So this is saying that obviously the candidate would love to have a match score of 100%. But this is the value that they're willing to settle for. So we've set this pretty low. So they're each going to have a win threshold between 20 and 30%. So this is a pretty this is already a pretty jaded and fed up voting community. So they're willing to settle to keep their the folks who have a match score of 0 from winning. And then this is how important it is for them that their candidate wins. Or if you like, this is how important it is that they defeat their opposed candidate. This is where the numbers get a little bit exaggerated, I think, because this is, in order for us to observe the spoiler effect, I've had to turn this up to between 1 and 5. You'll recall that or I'll remind you that the match score can be anywhere from 0 to 1, so it's a 0% to 100%. So this is saying that winning importance needs to be either equally important with having a good match score or 5 times as important as having a good match score. Now, I think that those numbers are artificially high because we only have 2 dimensions and a total of 20 issues. So later we'll try changing this to 3 or 4 and see if we can still get the spoiler effect with these numbers made more reasonable, I think. Or maybe these are reasonable numbers, who knows. I wouldn't, on further reflection, I wouldn't assign too much value to these since we're kind of arbitrarily imposing numerical values on human thought and behavior. So I wouldn't put too much stock in the relative size of these. So that's the first thing we have to change. The second thing we're going to change is that I've moved the voter generation out of the time loop and into the initialization. So we're only getting one set of voters. And we're not going to randomly generate those voters. We're going to give those voters specific leanings. So with 2 dimensions, we're going to have voters in the 1, 1 block, the -1, 1 block, the -1, -1 block, and the 1, -1 block. And then basically these numbers over here just determine the percentages. These are just selected to give us an imbalance. So instead of having a nice uniformly distributed population, we've got a pretty heavy imbalance. So the majority of voters are in either the 1, 1 or the -1, -1 blocks. So we're leaning heavily already toward a one-dimensional system as opposed to a two-dimensional system because 60% of the voters are at the 1, 1, -1, -1 corners. And so that leaves 15% of voters in the -1, 1 block and the 1, -1 block each. And we've got slightly more in the 1, 1. Let's see. The next thing we need to change, so we're leaving the match score calculation just as it was before, and we're leaving the candidate population satisfaction just as it was before. So this, I want my candidate to win, I want your candidate to lose mentality does not factor into satisfaction, because just because you voted for somebody doesn't mean you were satisfied with them. And I need to stop right there or else I will ruin my disclaimer from the first video. Here what we're doing is we're saying if the year is greater than 1, because there can't be a spoiler effect in the first year, right? Because let's say we're starting with a new country or a new set of parties or a new whatever, and so the spoiler effect has not taken place. We're entering into the first election completely naively to the way the election is going to go. Or if you like, this is before the first poll gets conducted of the candidates. And so we've got our match score being compared with the win threshold. And so if the match score is greater than the win threshold, then the candidate is willing to then the voter is willing to reconsider the candidate based on how well the candidate did last time. And so here we're adding to them this factor that's weighted by the win importance. So the more important that is, then the higher this is going to be. And it's weighted by the number of votes that candidate got last time. So it's not entirely adding a number between 1 and 5. It's adding a number between 1 and 5 multiplied by a number that is less than 1. So it's not like we're completely overweighing the match score there. And so we're taking this vote percentage from last time. So the better the candidate did last time, the more likely they are to vote for that candidate. And speaking of candidates, I guess I didn't show our candidate list. Up here, we've just got our standard list of somebody in the 1-1 corner, somebody in the -1-1 corner, somebody in the -1-1 corner, somebody in the 1-1 corner. And I realized as I was, and Tom at 0-0. Tom is refusing to drop out of the race. Kudos to you, Tom, for your perseverance. I suppose what we need to add next is a dimension for evaluating candidate perseverance and seeing how important that needs to be among voters for that to push Tom ahead. That's the other thing. We don't have anybody dropping out of the race yet. I haven't factored that in. Although this spoiler on the spoiler effect, this is going to show you why candidates drop out. So in order to help us keep track of who these candidates are, I've added these plus, minus, plus, etc. to them so we can remember which quadrant they're in terms of their leaning. Okay. And also that way we can match it with these percentages because currently our plus person has the majority. Our negative person has, well, not the majority. They have the most. I will not go on a rant about the difference between majority and most. Negative comes in at a close second, and then negative plus negative have 15% each. Okay, so we talked about the adjustment to the match score. Votes get assigned the same way as before, and now I've decided to get rid of the calculation of the satisfaction graph. It just doesn't it doesn't add a whole lot to this study. I don't think what we're more interested in is how many votes each candidate got each election cycle. And in fact, if I'm not doing the graph, I can take out this block as well, save just a little bit of computer time. And then I'm saving your time, although I just wasted your time by commenting that out and commenting on it now. Okay, so let's run it and see what we get. So what we're looking at now is the votes over time. Let's keep an eye out on these percentages because this is the percentage for the plus, minus, plus, etc. All right, candidates, show us your votes. Okay, so let's go up to the first year. Don't look down here. That's spoiling the spoiler effect. Let's see how many puns I can make on spoiler effect. Okay, not terribly surprising. Actually, a little bit surprising. How does Sue get 35% of the vote if she has 31% of the voters? Did I not set this up correctly? Hang on. What's my in-voters? Okay, my in-voters is 20. Okay, so that's not exactly breaking down. Okay, yeah, so those numbers are not going to match exactly, just because there's not a nice even division of 20 into 31%. So actually, why don't we increase the number of voters? I did not think about that. Let's increase in just a second. We've got data to look at here. Never waste data. Okay, so not surprising, our plus candidate got the most amount of votes, and our minus candidate got the second most amount. Right, that matches up with the relative distribution, or at least with the ordering of the population distribution here. We had the most in the plus corner, and the second most in -1, and then the least in these two. Those two are not exactly equal because we're just cutting this off at in voters. So this one is like getting the remainder in a division problem, which is unfortunate. Ask any third grader. Nobody wants to be the remainder. And then Tom, of course, gets 0%. No surprise there. What happens in the second year is Deb is still doing all right. Right, so Deb's voters are saying, hey, we got second place last time. That's not bad. Let's continue to push for Deb. But the plus minus and minus plus folks are not terribly happy that their candidate got 20% and 15% last time. And so what happens is John and Bob in the second year, so the minus plus and plus minus candidates, lose some votes that end up going to Sue because they don't want to see the opposite person winning, right? So John and Bob are opposite of each other. And so their voters don't want to see the other candidate win, or they don't want to see somebody who's opposite of them winning. And so ironically enough, they go and vote for the same person. Or maybe they don't all do that. Maybe some of them go to Sue and some of them go to Deb, or maybe some of Deb's go here. I suppose I could keep track of, that would be a bit complicated to keep track of who lost how many votes to who. I'll have to think about a way to do that. If I can figure out a way to do that, I'll post that as a bonus video. Either way, Sue ends up getting more of the vote here. In year 3, the effect gets exacerbated, and so Bob has completely lost all of his votes. So at this point, Bob is effectively no longer in the race after just 2 election cycles. By year 4, John is completely out of the race, and it's between Sue and Deb. And of course, by year 5, it's just repeating that. So basically, once we get to this point where we have only 2 candidates, or where we have only votes going to 2 candidates, it's basically a stable fixed point. And this, dear children, is how a 2-party system is born. And of course, you notice population not more than about 50% happy. Now that's a little bit arbitrary, or not arbitrary, artificial with 20 candidates. I think I meant to increase that, or 20 voters, excuse me. Let's change that to 100 voters, and let's see how our candidates fare in this population. Okay, numbers are a little bit different. You notice we start out slightly more equitable. Bob ends up with a greater percentage there. Oh, did I do that math wrong? This is... Oh, you know what? Oh, gosh. Sorry. I've been working with a lot of angles lately on black hole battles, and so I've been used to thinking in terms of things adding up to 90, not things adding up to 100. They should have 31, 29, 15, and 25. Because this makes 60, this makes 75, and 100 minus 75 is 25, not 15. That would be 90 minus 75. My bad. Okay, but much the same thing happens. The population's vision of the election has been spoiled. John's voters are not terribly happy with his performance, so they start splitting their votes. And now here's the interesting thing. Bob's voters are pretty satisfied with the turnout from before. Bob's voters are saying, hey, you know what? It's 25 versus 31. We've got a shot next year. But then they don't have a shot next year. And so then in year 3, then Bob's voters start exhibiting the spoiler effect. So the spoiler effect doesn't hurt Bob until after it's hurt John. And so the voters in John's camp are now having an effect on the voters in Bob's camp until eventually, again, by the time we get to year 4, actually, Bob is able to last until year 4 because of that delay. It's not until year 5 that we get down to basically a split population there. Notice that the average satisfaction went down a little bit. Now I wouldn't put too much stock in that number right now because we're only doing 5 election cycles. But things have gotten down to an equilibrium down here. Okay, let's see what happens. I haven't tried this one yet. Let's see what happens if we increase the number of dimensions to 3. And let's actually leave our voting pool a little bit limited. So for our candidates, let's randomly assign, well, not randomly, let's not have 8 candidates like we've done before. Let's have half of them with a +1 and half of them with a -1. Only I don't want that to I don't want that to correlate with anything. -1 and 1. Okay, so we've got let's see, we've got a 1 and a 1 on 1 and 3. -1 and a -1, -1, negative. Okay, so those are so the 1 and 3 are correlating. So 1 and 3 might as well be the same thing. Let's do that, maybe. Okay. So so let's have this represent this third one represent a horribly unpopular opinion among most of the candidates, but Sue holds that opinion. And then Tom, you know what, Tom? Let's say that's the one category of issues that you care about. Okay, so that means I need to adjust my voter list. Should we have them match the candidates? I suppose I could randomize that one. Yeah, actually, let's start out with that one matching. So I need to go 1 and then the rest -1. Let's see if that gives Tom a chance. Let's see here. Let's give you a 1 and let's give you a -1. And the beautiful thing is, if I want to go back to I can leave these in, and if I want to go back to having just 2 dimensions, all I have to do is change indim back to 2, and then it ignores this column. Okay, let's see what that does. And we're still got 100 voters. Okay, interestingly enough, that changes the ultimate outcome. Tom's still getting 0 in the first round. Let's see here. So again, John has the fewest here, and so John's votes get split between those. It's almost as if the folks in John's camp wanted to have a second decision and wanted to be able to split their votes among their second most popular choice. There's a spoiler for the next and probably last video in this series. By year 3, John is effectively out of the race. The spoiler effect has taken on Bob. But now Deb is the one getting some votes here. Again, probably because she's matching in the third dimension now. And so Deb is... Oh yeah, the reason Sue was getting all of those before probably was because she comes first on the ballot list. I haven't made an adjustment for that yet, but I mean the point is to illustrate the effect anyway. Oh yeah, our population is 53% happy. All right, Tom is still left far behind here. Okay, let's try one last thing. Let's see what happens if we randomly distribute this leaning. So let's say lean 3 equals uniform between -1 and 1, and then we'll call this one lean 3, and we'll just put that into every block here. So everybody leans sometimes. Let's see, lean 3. I have learned to not trust my fingers to type things, so copy paste is my friend. Oh, actually, what might be interesting to try would be to leave this third thing randomized, or not randomized, but leave this one, let this thing change every year for the candidates based on how the population's responding. Okay, so so not much different, except Bob did. The main difference here is that Bob feels the impact of the spoiler effect earlier. Deb gets a little bit more of the votes earlier on, and so the spoiler effect is still happening. It's happening a little bit faster now that we've got that randomized in there. Okay, one last thing to take a look at. Let's suppose we lower this win importance variable. So let's say we were originally at 1 to 5. Now let's make it 0.5 to 3. What we'll see is that it takes a little bit longer for the spoiler effect to come into play. So John doesn't drop out of the race quite yet. It's not until, year 4 he's down to 1% of the vote. Year 5, Bob is down to 3% of the vote. So that ekes it out a little bit longer. If you think of that as like an exponential decay almost. This is like broadening out the decay pattern. Let's increase the number of years to see if we can get that down to 0. So by year... looks like year 7. So now it takes 7 years instead of 3 years for the... it takes 8 years. Oh no, Bob still has some. I should read before I speak. 10 years. It takes all of 10 years instead of 2 or 3 years for us to end up with a two-party system, all based on, changing that win importance variable. But still, that's... we can have a pretty rapid onset of the spoiler effect. By year 3, John is down to less than 10% of the vote. So we've already, effectively got this category dropped out of the race by that point, because then it goes down to 5 and 3. So this has been interesting to look at. It definitely shows you that it does impact the outcome based on how people think about their voting. And so what we're going to take a look at next time is, what if we allowed people to have that sort of thinking process in the voting process itself from the beginning, instead of having it have to go through all these iterations and go through all these different results that result in less than 50, somebody with less than 50% winning, just because they happen to have the fewest objectors. We'll take a look at how that might affect our results. So thank you so much for watching. I will see you next time. Bye-bye.